Welcome back to part 2 of section 421. You should be recognizing the similarities to when we did this earlier in the chapter with our quadratics. And actually, here's another quadratic, the parent function, y equals x squared. So my anchor points, 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. Now, my values for a, h, and k. A is a negative 1, h is in 3, but negative 3, watch your signs, and k is 2. So now, when a is negative 1, that's an x-axis reflection. H is negative 3, so we're going to shift left 3, and then k is 2, so we're going to go up 2. So go left 3, up 2 for each one of those. Oh, excuse me. We have to take care of the reflection first. So I'm going to multiply my y values, my outputs, by negative 1. 0 times negative 1 is still 0. 1 times negative 1 is negative 1. 4 times negative 1 is negative 4. 9 times negative 1 is negative 9. Then we're going to take each point and go to the left 3 and up 2. I'm going to use an open dot to differentiate. Left 3 up 2. Left 3 up 2. And there is our graph. So our domain, it's a quadratic, so it's all real numbers. And our range, because it's going down, our values for y are less than or equal to positive 2. Next, we have an absolute value function. So y equals the absolute value of x is our parent function. It's going to put a couple on there. It's going to have that V shape to it. I'll show you a quicker way to do this in the next chapter, or later on in this chapter, excuse me. So now our value for a, negative 2h, is in positive 2, but it's also a negative 2, and k is a negative 4. When a is negative 2, that's an x-axis reflection because it's negative. Also, it has a vertical stretch. We can do that both in one step. Then we're going to shift left 2 and down 4. I'm going to take care of my reflection and stretch first. I'm going to multiply the outputs by negative 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. So there's a bunch of points, and now we're going to take each one and go to the left 2 and down 4. Left 2, down 4. Here's a point using an open dot. Left 2, down 4. Left 2, down 4. Left 2, down 4. Excuse me, wrong spot. Left 2, down 4, excuse me. Left 2, down 4. And there is good enough for us. There's our absolute value graph. So our domain, all real numbers, it goes all the way left, all the way right. And our range, y is less than or equal to negative 4. Like I said, I have a quick way to graph those absolute value functions, but I want you to recognize how it relates to all the other functions. All right, on the next page, we're going to be writing our functions. So looking at this, the parent, y equals x squared. So we need to find out what a is, what h is, and what k is. Now a, if I look, I'm going from here to my next point there. So you can see normally it's a 1. In this case, it's going to be a 3 because we're stretching it 3. H, from the origin where it's normally at, we're going to the left 2. So it's going to be a negative 2. And then k, from the origin, we're going down 5. So it's a negative 5. So y equals a, quantity of x minus h squared plus k. We're going to fill in our values. So y equals 3 x minus negative 2 squared plus negative 5. So when we clean that up, y equals 3 x plus 2 squared minus 5. That's our function. Now, a is a little bit more difficult to find. We'll be talking more about this as finding a little bit more algebraically as we go through. So now, this, the parent for b, that's the shape of a cubic. So y equals x cubed. You can see that point that's normally at 0, 0, and to the next whole number, it's at 1. So for this one, a is 1. So we just need to find our h and k. That's shifting from that origin here at 0, 0. So we went over 1, 2, 3, and then up 2. So h is a positive 3, and we're going up, so k is a positive 2. So y equals a, x minus h cubed plus k. So y equals 1, x minus 3 squared plus 2. So we can write it as y equals the quantity of x minus 3 squared plus 2. Let's do some more of these. For c. Now, looking at these, our horizontal asymptote is at y equals negative 4. Now, if you look at the values, we're going up 1, then up 2, and then up 4. So what this is, y equals 2 to the x is the parent function. A is going to be 1. And now what we're doing, and this is just a possible, for our h and k. I don't know if we're moving left or right at all. But I do know that our asymptote moved down 4. So k is negative 4. So y equals a times b to the x minus h plus k. So when we fill in our values, y equals a, which is 1, times b, which is 2 to the x minus h, which is 0, plus negative 4. So when we clean that up, y equals 2 to the x minus 4. That one's a little bit trickier. Like I said, we're just kind of practicing these on how things are moving. For part D, I can see the horizontal asymptote is here at y equals 2. I can also see that my vertical asymptote is at x equals 4. Now, I'm going to tell you right now, this is y equals 1 over x for the parent function, and my a value is 1. It's kind of tricky to calculate that with what we know, but I'm telling you that's what it's going to be. So now my value for h, I'm shifting to the right 4 and then up 2. So h is 4 and k is 2. So the function y equals a times the quantity of 1 over x minus h plus k. So we're filling in our values. So y equals 1 times 1 over x minus 4 plus 2. So we could write that as y equals 1 over the quantity of x minus 4 plus 2. This is really just an exercise in seeing how the graph moves on the coordinate plane. E, the parent function, y equals x squared. Since what it's doing is to get to the first point, it's just going 1. A is 1. I'm telling you that's what it is. I know that's a little bit trickier to find. Now h, we're shifting. Oh, excuse me. A isn't 1 because it's opening down. A is a negative 1. Now h, we're shifting from the origin. We're going over to the right 4 and then up 5. So we're going h is a positive 4 and k is a positive 5. So y equals a times the quantity of x minus h squared plus k. So y equals a, which is negative 1, x minus 4 squared plus 5. So you commonly see it written as y equals, without the negative one, but just a negative, x minus 4 squared plus 5. And then finally f, the parent function is y equals x cubed. I'll tell you right now that a is not a positive 1 because normally a cubic goes like that. So a, it's got that x-axis reflection, it's a negative 1. H, we're moving from the origin to this point, so we're going to go to the left 2, and then we're going to go down 3, so k is a negative 3. So y equals a, x minus h squared plus k, y equals negative 1, x minus negative 2 squared plus negative 3. So when we clean that up, y equals, we usually just see a negative, becomes x plus 2 squared minus 3. And there is our function. Like I said, I'm just practicing moving those around. We'll be talking more about this as well in the next lesson. Thank you and have a nice